Welcome, everyone. Thank you for coming. My name is Ann Hopkins. I'm the Leadership Fellow for our Cloud Track community. If you haven't heard about our track communities that we've launched this year or that we are building out, if you are interested in cloud computing, you can join us at womenwhocode.com/cloud and become a member, and you'll get notified of different events and participate in workshops and see our job board and things like that, all wonderful things that are Women Who Code stuff. So it is my pleasure to be able to introduce the next speaker, which we are live streaming today from Connect. So she is a senior data engineer from Microsoft. Please give her a warm welcome for Muazma Zahid.
Hello, everyone. My name is Muazma, and I am a senior data engineer in Microsoft Azure. And I'm here to talk about building big data pipelines in the cloud. A little bit about myself. As I said, I'm a senior data engineer in a team called DataCat. CAT stands for Customer Advisory Team. I work with a broad spectrum of customers in a lot of different industries to onboard them to Microsoft Azure platform, which is the cloud offering for Microsoft. In the past, I've worked in AWS as well and other customers. So I have a wide experience in a lot of different cloud platforms, starting from 2012. I'm a mother of 3 beautiful girls, including twins, so I can multitask. And I am a big advocate of diversity and inclusion at workplace. And I'm also a Connect lead for Pakistani women in computing in Seattle. So just to level set, how many of you actually use some sort of cloud computing? Great. How many of you have used or are using a big data technology? Great. And how many of you work as a data engineer, architect, analyst, some kind of data role? Okay, that's great. So I just start off by giving you an idea what the big data is in this age. According to economists, data is the new oil. That means that's the most valuable resource right now. And I love this quote by Kate, who is the VP of DreamWorks, that data is the new oil, AI is the new electricity, and IoT is the new nervous system. And to highlight one thing here, there is 150 zettabytes of data that is going to be there by 2025. Let that sink in. That is thrice as much as data as we have today. So that means we need a lot more data professionals in the field working with this data to analyze this data and making sense of this data. How do you do that? That's where this talk is. So where do you start? Technologies like microservices, IoT, serverless, all of that is very intimidating. Let's start with the basics. What is cloud computing? Cloud computing is just a bunch of rented computers by a cloud provider. You pay as you go. You bring your services, your applications, your code, your infrastructure to them, and you run on that piece of software or hardware. The thing that comes with cloud is the scale. So for example, if you have an application today which needs 10,000 users, and tomorrow you need 100,000 users, if you are in an on-premise world, it would take 3 to 5 months, in some cases maybe a year, just to get that kind of hardware installed and up and running for your applications to scale at that level. In cloud, you can do so with a click of a few buttons, and you're up and running with that kind of scale. Of course, you have to know that it comes at a cost. But it provides you the scalability to do that kind of work. And you have a lot of those different cloud providers out there. So your choices are unlimited. You can start at one point and then go take your application from one to another. If that doesn't fit your use case, you can actually expand it to others as well. This is an independent survey. And as you can see, Amazon AWS is the market leader right now, followed by Microsoft Azure, Google Cloud, Alibaba, IBM, and many others that are following up. And you can see the growth year over year. And this is not stopping anytime soon. All these competitors are out in the market to get you and your organization and your applications and code to those platforms. So how do you start that journey? Let's start by dissecting some of these terminologies. These are different types of services that are available in cloud right now. And this is a terminology that you need to be understanding before you start choosing any of the things that you run on cloud. What is infrastructure as a service? It's called IaaS. That means that you are actually bringing your code. The infrastructure is the cloud provider responsibility. For example, Microsoft provides Azure VMs. So you can bring your code and application to them, and then with a click of a few buttons, you can scale up and scale down. Amazon has a thing called EC2. That's also a bunch of machines. You can bring the code to them and do the same thing. Google has something similar as well, and so on and so forth. That's infrastructure as a service. So you have that kind of service available that you can choose to run your code and applications. The second one is platform as a service. That is gaining a lot of interest these days because in that case, you don't really need to manage the platform. You don't need to do the upgrades. You don't need to do anything on the platform. The cloud provider takes care of those things. All you need to take care is your code and application. So the example of those kind of services include like a Hadoop service in Microsoft Azure called HT Insight. There is relational databases in the Amazon cloud. You can bring them up in a few minutes, and then with a click of a few buttons, you can scale up and scale down. And you never have to worry about any upgrades or downgrades. They send you a notification when it is ready to be upgraded or something needs to be done. So platform is not your responsibility in that case. Third one is a software as a service. Gmail is an example of that. How many of you use Gmail? So everything is Google's responsibility in that case. You just use from your client or web browser the application. That is a software as a service. It's running on a back end with a bunch of machines, there's a bunch of data, and a bunch of data pipelines behind it. And finally, this is gaining a lot of interest these days. As I work with customers, I see a lot of people turning and using this more and more. It's function as a service or serverless computing. What it means is that you are only responsible for the code. You bring your code with a function, you write that code, and that's it. You never have to worry about anything else. How to scale up, scale down, what to do about that code is the cloud provider responsibility. An example of that is Amazon Lambda. Azure has a thing called functions. Google Cloud Platform has functions as well. So all those little functions are little microprocesses that you can do to run your application. Again, that could be written in any language of your choice. Each of these cloud providers actually have support for all the open source languages out there. So you just bring your code to perform a little action, and then the cloud provider takes care of the server. You never need to even know about where that server is, because that's the cloud provider responsibility. And there's another one that I didn't mention here, that's container as a service. That's a talk in itself. So that would be some other time. That's also gaining a lot of interest these days. So microservices, Kubernetes, all those, that is the thing these days. Every application is kind of using that. So you need to know about these services in order to know how do you take your data from the on-premises world to cloud. If you don't understand the difference, you will not understand what to do when you have to scale up, scale down, or scale in and scale out. This is just another graphic of the same thing. So you can see from left to right, in an on-premise world, you are in charge of everything, including the hardware, software, application code. As you move from IaaS to containers to platform to functions as a service, you lose that control, but you gain the scalability. Where you don't have to worry about the upgrades, the downgrades. You don't have to be a database administrator to do those things. Cloud provider takes care of those things. All you worry about is your code and the application and the thing that you want to do for your organization. So let's start about talking what is a big data and what is a big data pipeline. This is one of my favorite visuals. I saw that in a HopperX Seattle conference a couple of weeks ago. each organization out there has data. All of you working in any organization has a bunch of data lying somewhere. How do you take the data, convert it into a piece of information, to knowledge, wisdom, and finally make it an impact for an organization? That's the goal of why we have these job roles out there. A lot of organizations and companies when I work with, and customers, they come to us, they just say, okay, we have data, we don't know what to do. Or they start from this side and say, we want to make our company do this, this, this by this time. How do you do that? How do you find out the data? How do you make the dots connect? And how do you convert that into some piece of insight and make an impact for the organization? You have to start building your data pipelines. And as this talk is for cloud, you don't need to use cloud to do that. You can start doing in a local server somewhere and eventually move to cloud as well. But I'm going to talk about what are the different options you have in cloud environment to actually start doing that. So this is one of the architectures that I've seen a lot of companies use. Again, this talk is not for you to actually take this and just start implementing this architecture. One of my mentors once said to me, there's no architecture which is good or bad. Every architecture has pros and cons. And every architecture is supposed to do the work that you're trying to do. If you know what your goal is, you can start looking at different things and options in the cloud and start running a bunch of proof of concepts in those and see which one of that works for you. Just to put it out there, this is something that I'm seeing a lot in the industry right now, where you have a bunch of sources. There's a bunch of event data. It could be a sensor data. It could be an Excel sheet sitting on somebody's computer, where you actually have two parts of that. There is a streaming path, which is the hot path on the top. For example, when you get a message on your mobile phone telling you about that something has happened on your credit card, that piece of information actually came from this pipeline. Somebody had built that pipeline. So that kind of anomaly detection of your credit card activity is near real time. Somebody notified some system that something wrong is happening on that credit card. That's this speed layer or the hot path. The second one is the cold path, which you do for your traditional BI reporting or the data lakes of the world, where you store each and every piece of information that you're getting for future analytics, for the use cases that you don't know right now. They might be coming in a year later, or your company might be pivoting your business in a year or so. You would need that data somewhere. So this cold path is usually cheaper, and you can store a huge amount of data with a fraction of cost. And again, each of these the cloud providers have a bunch of offerings in those. Amazon has S3, AWS, Amazon has S3, as I said. Microsoft Azure has a data lake storage N2. Google has their own, and so on and so forth. Finally, there's some kind of serving layer. And it's usually batch-based. You can make it micro-batch as well, which is usually some kind of database, where you actually do the transactional as well as your history data, and you do aggregations on top of that. And all of us like to see visuals, right? So there's usually some kind of front-end application running, which actually looks at the data and provides you the visual. Again, each of these cloud providers have their own. If you want to be a cloud-agnostic environment, you can use a third party, like Tableau. Microsoft has Power BI, Amazon has QuickSight, so on and so forth. But you can bring your own, whatever you're using right now in your organization. A lot of those have connectors to cloud. So you can connect to any of these serving layers. This is how, just another diagram of the same thing that I was talking about in terms of cloud. You start with data sources, as I said. That could be in any form. It could be structured, unstructured. It could be a sensor data, IoT data, anything. From there on, you have options. You can go the ingest route for a real-time ingestion, where you can actually use technologies like Kafka and others. Or you can use a cold path, where you store the data. Again, that's some sort of data lake, where you dump all your history, all of the data that's coming from all these sources. And that could be coming at different frequencies as well. On top of that, you have your data analysts, your data scientists, your data engineers. They could be running those machine learning algorithms either on near real time or on the data cold storage, where all the history of their data is. One of the examples is Amazon online shopping. How many of you have done that shopping? All of us, right? So you've seen the recommendation that pops up. Sometimes super annoying, sometimes really cool, because that's exactly what you're looking for. How do they know about you? That's all the data they've collected in the past, and all the clicks, all the information that you've given them. That's somewhere stored in some kind of cold storage for all the history. And some of the latest transactions might be coming in from the real time. That's what you're doing in that window. And based on that combined information, they have some kind of algorithm running that tells you, oh, you might be needing diapers of this size right now. And that's what happened just like last week with me. They knew that somehow my daughter is actually now a size something. So that is how specific they are. So that means that somebody has done a really good job in this data pipeline for them. And that's the power of cloud. That's the power of the kind of data that we have out there. Finally, most of the traditional organizations, they have some kind of analytical data store. As I said, it's kind of data warehouse. Again, different cloud providers have their own. Amazon has Redshift. Microsoft Azure has SQLDW. Google has BigQuery. If you don't want to be any cloud specific, you can use cloud agnostic snowflakes of the world. You can connect that to any cloud. And finally, the reporting. So again, all those technologies are out there. And an important thing that I've missed here is the orchestration. So you usually need some kind of thing to actually run the data from point A to point B on some kind of schedule, usually in batch world. If it's real time, then Kafka takes care of it. So that is another thing you need to worry about. So again, your technology options, AWS has a thing called Glue. Amazon has a data factory. Azure has data factory. Google, I'm forgetting what they have, but there's something similar to that you can use. Or you can bring your own, like Informatica, Talent, and so on and so forth. So as I talked about the different steps, these are all the things you need to worry about at every step in the options that are out there. The cloud world is haunting. It's intimidating. Every other day there is a new service out there. You need to know why you are not using that or why you should be using that if you've built some of these pipelines. Sometimes it's not your job, some architect, somebody else's job, but it's always good to be informed about those. What is new out there? What are the new technologies? How can you leverage them? And how can you make your platform better and faster? So extraction, again, all the sources as I talked about, you need to know how to connect to them. In one survey, they found that most of the company's valuable data is actually sitting on people's laptops or desktops in Excel sheets most of the time. Everybody loves Excel. So how do you connect your real time to that? Again, there's so many options. We can talk offline on that. But you have to find out that data and how to extract it from those laptops into some kind of storage where everybody has access to that. How do you ingest the data again? Where do you ingest it? Is it real time? Is it going to be batch? Is it going to be micro batch? What's going to be the frequency of the data, and so on and so forth? How do and where do you store it? Again, plenty of options. Do you want to be a cold storage? What type of formats you have? Each format has its own pros and cons. Again, it's a talk in itself. You go with Parquet, ORC, Avro, so on and so forth. Do you want to use compression, non-compression? Talk right before me was about encryption. You need to know a data at rest and movement, how do you encrypt that? Because you don't want your system to be hacked. So all those choices with the different technologies are different. They're not all the same. Some tools are not available with some services. So you need to know why you're using that and how you can achieve what you want to achieve with those services. Finally, you have to prep and model the data for your data scientists or the business analyst. Again, in some sort of data warehouse or a SQL database or something like that. And visualization. So you need to know all these in order to build that data pipeline and be effective in your organization. Important concepts. This is a thing that I talk to customers all the time. They say, okay, we have this pipeline. We have been running this for 10 years now. We want to scale it. What are your options to scale? Do you scale the storage? Do you scale the compute? What do you want to do? You need to understand what those things are. In terms of compute, the big data world has a thing called Hadoop. How many of you know about it? Right? So Hadoop is just a bunch of nodes. They are in a cluster environment, and you can actually run a bunch of tasks on it at the same time. So it's like parallel processing at its best. But you have to tell her what to do. It doesn't work by itself. The very important thing is network and security. You cannot run these things if you don't understand these concepts. If your application is not secure, if you run something really, or build something really awesome, and in 10 days it gets hacked, it's of no use. You cannot go to a CEO and say, sorry, I lost all your data. Some of the applications, example applications, you use most of them. Alexa, how many of you have used that? So you talk to Alexa, tell about weather. How does it know what the weather is? There's a data pipeline that somebody wrote for it. That converts your voice into a command, and that gets the data about that information and returns that back to you. So on and so forth, like connected cars is a new thing. You can unlock your car from a click of a button sitting somewhere else. Again, there is a data pipeline behind it. The most recent and advanced application of cloud is disease detection. So cancer cure. The things that you couldn't do before is now possible with cloud because of the scale it provides, because the type of genes and analysis you can do in cloud and the processing that comes with cloud. Top considerations as a coder, as a developer, you have to know about all these things. You need to know how to automate your code, how to do CI/CD, how to actually do blue-green deployments before, like without affecting your production. How do you convert your dev, test, production, and deploy? Security networking, I cannot emphasize more. It's really important to have those concepts, the VNets, the roles, the users, the access, everything. Encryption. Very important, high availability and disaster recovery. 95% of the time, we talk to a customer, they say their app is down. They have lost a bunch of customers. What to do? Definitely somebody forgot about this. That's why that happened. In a cloud provider, it's just a data sitting in some server, right? They could get affected by a tornado someday. Hypothetical. So you need to think about what will happen if that happens. You need to have copies of your data and application. And most of these cloud providers come with concepts about availability sets and things like that, where you can duplicate the data by itself. You don't have to manually run those jobs. Scales, speed, and feeds. One day, if you were expecting like a Black Friday sale and your turn up is going to be 100,000 users, you need to know when to scale up and scale down, scale up, scale in and scale out. And the impact on cost. Because in the cloud world, with a few click of buttons, you can cost your company a few $1,000 in a minute. So you need to understand, by clicking those buttons, what are the impacts. And finally, monitoring. So if you're not monitoring those data pipelines, something goes down, you need to be alerted about it, what to do about it. And all of that needs to be part of your code. It doesn't need to be manual. Let's see it in action. So if any one of you is on Twitter right now, can you go ahead and tweet with this hash code, this hashtag? And we're going to see a real pipeline. So I have a very simple pipeline here, which is looking for a tweet, which includes a text with that hashtag. And I'm putting that in a SQL database. It's the simplest of the pipeline that I can build. And I've built that in like 10 minutes. And from that, I'm actually looking at locations of all the people that are in this conference. And I've been doing that for the last 2 days to collect all the tweets about this conference. So let's just see if we got any new. So these are all the people that out here tweeting, and this is the location of the actual Twitter account. So if, let's say, if I'm from Seattle, so mine is actually somewhere over there. That's the location that Twitter saves about your tweet. It's not the location from where you're tweeting, it's actually the user's location. And let me refresh it and see if I got new. Yep. Just to show you the raw data behind it, this is a simple table with Twitter. And this is before the talk started. Yeah, I've got some more. Anyone here is in this?
I just saw that we're trending in San Francisco with the WWCode.
Uh-huh. Yeah. So yeah, that's how simple it is to build a data pipeline in cloud. So I can take questions now. I have around 8 minutes.
I have a quick question. I was wondering, based on what you've been doing and the experience you have, what are some of the security models you've seen people implement that you've seen implemented with regards to pipeline, cloud pipeline, data pipelines?
Sure. So the question is around security models in the data pipelines. There are many options, as I said. So there is the encryption at rest and encryption in data movement. So for example, if you're using Kafka, you have to encrypt in motion. And then if you're using some kind of database, you can encrypt at rest. There are encryption models for databases. Then depending on the severity of the data, so if you have PIA, like personally identified data, then you have to do some kind of role-based access to your systems, where you control at the like IAM role level, who has access to what. And one of the things that I've seen at customers a lot is the admin type roles, they get hacked the first because they have access to everything. So you have to make sure that your super user doesn't have access to everything. Even though if they have access to run stuff, they shouldn't have access to see data. So you have to secure your data in forms of encryption, in forms of policies, and in forms of roles. And again, in terms of technologies, if you're in the Hadoop world, you can do that using Ranger. If you are in database, they have their own. Each database comes with its own encryption model, so you can choose those.
Have you seen customers have issues with the models, those security models, as far as impacting performance and so forth?
Yes, there is definitely a latency involved because it requires you to encrypt and decrypt when you actually access the data. Let's say you select start from table. It was just a talk right before me. That was the same question over there, where you are trying to access the data. That needs an extra few seconds to do that, sometimes milliseconds. But you have to do that for the sensitive data for sure. And then the question is, if the customers are seeing that, yes, there is some latency involved, but they're okay with that because if they get hacked, they will lose much more customers, and that happens all the time. Some of these big companies actually get hacked first, so you have to have those things in place, especially for your sensitive data.
Thank you.
No problem.
Hi. Hello, my name is Beverly, and I just wanted to find out, so you were talking about shared information. Do the larger companies like Microsoft or Amazon, do you all share information as well? Or is there some sort of privacy?
At some level, I think we do at some of these conferences and all, but I would not be the right person to comment on, like, if our cloud CEO goes and talks to the Amazon CEO. We do have ethics and compliance and things like that, where they share what is, like, for example, GDPR came last year or year before that. So they all sat together and actually talked about what to do, and because they have a bunch of data about a lot of customers. So what is the best practices to do that? And then, of course, they all implement in their own ways. That we cannot control, but there is some compliance level things that is there. But this, as I said, it's a very fast-growing market. Every other day, even in Azure, there is a new service. So I have to keep my skills up to actually find out why we are doing this. Oh, we had this service. Why are we adding a new one? Because somebody else did something. So that's a constant race we are in, and it's just the way it is right now.
great. I have a question. So why do you think that companies are going from serverless computing or functions as a service instead of infrastructure as a service or platform as a service? Like, why do you think that they're seeing a trend towards serverless computing?
Yeah, so as I talked earlier, there's a huge trend right now, but a lot of customers that I see, they're just in the POC phase where they're kind of doing some serverless, not fully, and it's actually a mix of infrastructure, platform, and serverless. I have not seen where everybody is on, let's say, function as a service, or everybody is on a platform as a service. It's always a mix of things. And some of those big organizations, they usually, I've seen, they start with either infrastructure as a service or platform. And once they are matured enough in cloud and they are okay with the way it is, then they start moving towards serverless. And I worked in Nordstrom before Microsoft, and there was a huge push for Nordstrom apps to actually use serverless, and we did the whole re-architecture of that, and it went really well. But we were already 3 years into Amazon AWS, and we knew the land and the landscape and the things that go with it, and then we started moving towards that. But a lot of these startups I talk to, they start usually from the other side, because they don't want to manage any servers. They don't want to have DBAs. They don't want to hire people who are just managing platforms. So it's a mix, but the big organizations, they start from infrastructure platform, then go to functions. Small, medium kind of organizations, they're kind of starting from the other side. Anyone else?
So someone trying to get into the cloud, so say, for instance, they're in another path, someone trying to get into the cloud industry, where should they start? How long does it take or to get, I guess, up to this?
Yeah, it's a really good question.
You have?
So there are a couple of ways. You can start with some online courses. Each of these providers have their own online courses, or you can start with third party like Coursera or something like that and take a specialization course where there's an end project that you do in the end to get your hands kind of dirty and understand what it takes to build in cloud. That's one way. Some of these organizations also have certification programs, which you can start doing that. Again, they come with a course, and then you do some kind of practical work and do that. How I started, I was working at a startup, and they were like, AWS is the thing, you should do it. So I just had to go and learn by myself, do a bunch of things, click here, there, and then figure out what I'm doing. So it could be an accident, or if you really want to learn, go into the cloud, then just start taking some courses. There are a bunch of conferences around it, like every company has a big conference. AWS has a reInvent, Microsoft has Ignite. GCP just had last week in San Francisco, the Google Next conference. They have coder sessions over there where you can go and learn hands-on. A bunch of stuff is free. So in cloud, if you want to learn, you can just go and start using free trials. Just be careful to know when that free trial ends, because it can go up very fast. Microsoft has a thing called MSTN subscription, which allows, I think, $150 credit to test things out, so you can do that as well. So all those things, you can run a bunch of POCs. How I would do it at this point is I would take a use case and then just build it. For example, just to repeat, for example. Just go in cloud and see how can I build it, and use different cloud environments. I have built the same thing in AWS and GCP as well, and just to see how it works. And it didn't cost me anything because I shut it down right away. So that's it. So that's how you can start, and you can go from there. Okay. So my last question.
You mentioned about monitoring.
Yeah.
So like in AWS we have CloudWatch or
Yes.
something. So in Azure, what you prefer, and how much it charge?
So charge I would not know on top of my head. It would be based on the type of data you have. But Azure has a thing called Azure Monitor.
Okay.
It uses log analytics on backend, and it's similar as CloudWatch. So you can build, put every service have a hook with that. They already have that, and you can build a monitor on that and see how each service is doing, and then you can build alerts on top of it. So GCP has something similar as well. So and the charge is usually very competitive in between those services. So if Amazon is charging you something, I wouldn't expect that it would be much different in Azure. Okay. And it's per request or per the data size. So if your data size like petabytes of data and you want alarms on that, then it might charge you more.
Yeah, and is there something like the code pipeline in Azure, AWS so you just built with something service like that? Like some service in Azure, like the code pipeline you used to build your pipeline? Or you started from the scratch, like the...
So this one was started from scratch. It wasn't a template or anything that I downloaded. It's a Logic Apps is a service that I used for this one. If you want to do that in AWS, you can use Glue. But for Twitter, to get the Twitter data, you have to create an app for it. So that app right now, I'm just using my account. You can use a service account to do that. So again, there would be some differences between these different cloud providers to do the same thing.
Yeah.
But you usually start with some kind of orchestrator. So in this case, it's Logic Apps or Data Factory. AWS has Glue for the same thing.
Okay, great. Thank you.
Thank you. That's it.
Okay, thank you everyone for attending, and thank you, Muaz Mazahi. Thank you.